chemical engineering can be used for a lot of good, but it's not something like.
So, welcome to the show, James Graves.
Thank you for having me.
No problem. So, for those who don't know, can you describe what chemical engineering is?
So, chemical engineering is also sometimes called process engineering. It's the sort of scaling up of in chemical industrial processes so they can be used in everyday products. So, like the most common uses you'll see are stuff like chemical water treatment or the production of medicines in pharmaceutical industry, or like the production of cleaning products is a big one as well, and obviously stuff like oil and gas and the hydrocarbon industry.
So, before we get into all of that, how did you get interested in chemical engineering?
Well, I've always been a big maths and science guy at school at GCSE. I enjoyed maths and I enjoyed chemistry, so sat down with the lady that did careers talks for me, and she asked, what sort of career do you want to go into and what subjects are you strong at? And I said, I'm very good at maths, physics, chemistry, and I'd like to do some type of engineering. So she recommended that I had a look into chemical engineering. So I had a look into it, looked into the courses I needed to do, the qualifications I needed. And I'm currently at university now studying chemical engineering.
So, what was it about chemical engineering that made you go, "That's it"?
I think one definitely would be I really love chemistry. And then the other would be the versatility of the degree. So I can go into pretty much any area of engineering I want to with the degree. And I can go into some non-engineering related fields as well. It's a very versatile degree.
Can you tell, explain to people, tell people what those industries are?
So the biggest employer of chemical engineers now two biggest are the oil and gas industry or the petroleum industry. So the fuel in your car, the extraction, the refining, that's all a chemical engineer's job. Or the plastics you use, the production of that on a big scale, a chemical engineer's job. Then there's obviously a lot of chemical engineers in water treatment, so making sure water's safe to drink for everyone. And I would say it's a growing sector, and the sector I'm looking to go into. It would be renewable energy production and sort of grid management, that sort of thing.
Yeah, because it's also in food as well. Because I had to look at the beer industry. I know that shocked
Uh,
me. Yeah,
yeah. So fermentation, I forgot about that, but yeah, fermentation is a big sort of thing we do as well. So obviously that would be alcohol production, beer specifically. I had a whole module this year actually where we were going over the processes of beer sort a beer reactor, a fermentation reactor to make beer, to make and produce beer. And yeah, it's food. And then the other one I forgot was, I think I mentioned it earlier, but pharmaceuticals as well, sort of making medicines and drugs on a sort of big scale so you can get it to as many people as possible.
just how widespread is chemical engineering used? If it's used in, like you said, water, pharmaceuticals, food, oil and
Um,
gas.
you you'll find chemical engineers sort of all across the world. The UK, it's a UK based company right now, but the ICME, or the Institute for Chemical Engineers, which I'm hoping to join one day as a fully qualified chemical engineer. It's based in the UK, but they have well, they have members in well over 70 countries, and they have offices in America and even some Southeast Asian countries like Malaysia, for example.
What do they do?
Again, it's all sort of similar things. So in in America, there's big oil and gas industry. In Southeast Asia and Malaysia particularly, you'd be looking at a lot of food production as well because they've got the palm oil industry and sort of trying to make that a bit more sustainable as well. Because obviously, to get, I don't know how much you know about palm oil, but to get it, involves the deforestation of the Borneo rainforest. So a lot of chemical engineers are working on that to make that more sustainable as well. So yeah.
Just how important is it to have chemical engineers in our industries, and what would a world without them look like? Because if they're so widespread, then it's clearly something important.
For starters, I don't think you'd have any beer anymore, which wouldn't be great. But I'd say you would finding stuff like, so the energy we use. Well, there would be ways to work around it without chemical engineers. We would suffer major energy shortages. The biggest one would be a lack. Biggest worldwide impact I could think of would be a lack of clean drinking water. I would say chemical engineers are possibly the most important step in water sanitation procedures. And if you remove chemical engineers from that overnight, for example, you'd be left with a massive lack of clean and safe drinking water very quickly.
Wouldn't we also be out of computers? Because I found out that chemical engineers also help develop like the chips and all that for CPUs in our computers.
They definitely help with that, but it's not one of those stuff like, say, water and energy are more sort of industries where chemical engineers are vital for how they function. So computer chip production, whilst an important role, it's not, chemical engineers don't necessarily play as pivotal of a role, if that makes sense.
Sure. So is it more like we need them, but they're not critical, unlike water and gas and gas and oil?
Yeah, that would make sense. Yeah.
Okay. So if anyone wants to become a chemical engineer, do they have to go to university?
Not necessarily, no. So I've chosen the university route, but you need a degree, but there's more than one way to get a degree. So you can choose to do a degree apprenticeship, and then you're typically aiming for a master's in engineering, and then you need to do and then most places want an extra accreditation on top of that, to become what's called a chartered engineer. But you can obviously get that through going to university or get that through doing a degree apprenticeship. But in general, you do need a degree. Yeah.
Right, that's where I was kind of coming from it at. For the audience, which university did you go to for your degree, and why did you pick it?
I'm currently studying at the University of Bath, and the way I chose it was quite simple, really. I looked out when I was choosing my universities, because I'm from sort of the southeast of England, near London. I didn't want to choose a university in and around London, so I simply went, what are the best universities for chemical engineering that I have the grades for that aren't in London? And that's pretty much how my applications went. So my first choice, Bath, was the best university I could get into with my grades outside of London.
So you just wanted to leave home and then hypothetically travel the world, but in your case, just travel somewhere else.
Yeah. Partly was leaving home, getting some independence, but also the UK is a deceptively big place, and I haven't, before starting university, I hadn't really seen a lot of it. So obviously I'd seen parts of the southwest of England when I came to visit you, and I know sort of London in the southeast fairly well, but Bath's a city I'd never been to before university, and it gave me a chance to explore somewhere completely new. Yeah.
And your uni course facilitated that, didn't it?
Yeah. And the other thing my uni course and the university does is gives me the opportunity to meet people from sort of all around the world that otherwise I wouldn't have the opportunity to do so, basically.
Oh, so you got international students as well.
Yeah, quite a few international students. So in my first accommodation at uni, one of my neighbors was Malaysian and doing sort of mechanical engineering, so I got to get to know him quite well. It's quite fun just meeting so many different people, basically.
That sounds quite interesting, actually.
Yeah.
How long is your uni course?
So I'm doing an integrated master's with a year's placement for work. So my course ends up totaling to 5 years, which is pretty much on the top end of how long you'd expect a chemical engineering degree to take. Most take 3 or 4 normally, though.
And what's exactly involved in this course, like module-wise? What do you have to learn? Because you mentioned about that one module about beer brewery. What
So
others do you have to do?
So it's split into sort of 4 main modules which we carry on. So you have first module, which is the maths and sciences of engineering. So that's just reaffirming your knowledge on maths, chemistry, physics, biology, and then going into next year it will be a bit more computer science and coding and use of computer software as well. Then you've got skills, practical skills and designs, where the majority of it is you're either split into 3 bits. That way you're either presenting your ideas or your findings to a group of people, you're designing so this year we were designing a reactor to separate 2 different molecules of oil from each other, and then a lot of it's also lab work as well. So I think I had 6 or 7 lab practicals. Third one, and the biggest one, is principles of engineering, where it's where I learned about the reactor and stuff. They sort of take you through different engineering principles, so like fluid mechanics, heat transfer, energy balances, mass balances, that sort of thing. And then the final one's sort of what's called a professional portfolio, which is trying to set you up with the skills to go into the working world and having the right mindset for that.
So, how does the aspiring to the master's part fit into all of that?
So in the UK, and it's recognized worldwide, but predominantly for the UK, for high paying chemical engineering roles, you need to be what's called a chartered chemical engineer. And to do that, you need 2 things. You need, one, a master's degree or equivalent in chemical engineering or a related discipline. And then you need what's called, I'm hoping I'm getting this right, but an ACTS, which is an accredited sort of chartered training scheme that either you pay for yourself or your workplace pays for you to get you the extra accreditation to become a fully chartered engineer. So I chose the master's so I could get that first step sort of in line with my university education.
So, once you get your master's degree, what are you planning to go into? Chemical engineering wise, obviously.
I've thought about 3 areas. The first one would be going into renewable energy, because it's a massively growing sector. Secondly, water sanitation and treatment, because it gives me the ability to sort of work worldwide, because there's huge need for sanitation work in sort of developing countries. And the third one would be sort of pharmaceuticals, because while I haven't done much education in it, stuff like medicine and how drugs work and sort of the processes behind that also really interest me.
What is it about each of those industries that you kind of drawn to? Because it seems like you've mentioned it, but what specifically?
So for renewables, I think it's clear that while I'm not going to get into the politics of it too much, but while there were some political holdouts on renewable energy production, the general global shift is away from oil and gas and towards renewable energy. So I'd like to get on that, try and catch that wave while I still have the opportunity to, while there's still a lot of growth in the sector. Water and sanitation, it would be sort of a more sort of personal moral thing for me, where I believe everyone deserves clean drinking water, and it would give me the opportunity to go to parts of the world which don't have free, don't have clean, easily accessible drinking water, and bring that to them. And then pharmaceuticals, like I said, it's just something that really interests me. I think it's partly some of my uni friends do stuff like pharmacology and pharmacy, and they say it's a lot of chemistry. And like I said before, I'm a big fan of chemistry, so going into a more chemistry heavy field would be something that interested me.
Would you say all of that's more of a benefit to humanity? Like all those reasons make chemical engineering more of a, I want to say, noble career. If you catch my drift, is you can go into it for good intentions.
Yeah, I'd say you can definitely go into chemical engineering with positive intentions, looking for the betterment of society. And I'd say the areas I've chosen, well, obviously they are all compensated very well as well, which is a nice bonus. They are also sectors where you can feel like you're making a positive change in people's lives, which is also a really nice bonus.
Is there any drawbacks or any potential threats to someone using chemical engineering to humanity that you can think of?
The oil and gas is a huge one. Plastic, chemical engineering, sort of as a profession, have been one of the slower professions to move away from getting involved in oil and gas, because traditionally so many people have been reliant on it for jobs, for example. So it'd be fair to say historically chemical engineers have played a big role in climate change. Obviously there has to be the political will behind that, but you still have to choose to work for it, and even now it's still quite resistant to change in that regard. So yeah, chemical engineering can be used for a lot of good, but it's not something like medicine where no matter, you can go into professions which people would argue aren't as good for society as others.
Which ones would you personally say are good for society and which ones are bad?
I think it's tough to say because I can't speak for everyone. Because while I'd say going going into oil and gas now is potentially not great because it's contributing to climate change, 50 years ago, when we're still trying to get everyone electricity and energy, you couldn't criticize it and say someone's work, someone's doing oil and gas work in a country that's currently got a low access to electricity in sort of sub-Saharan Africa or Southeast Asia, etc. You can't then say it's a bad thing necessarily. So I think it's dependent on case to case, and you got to sort of take a step back and look at it properly.
Do you think AI would help with all of that? Because I know I've seen a video with they had AI use this robot to do a bunch of formulas, and it did something like I think it was like 17 in like half an hour or something. I can't remember exactly.
Yeah. I think with all industries, the responsible use of AI can and should be a massive benefit. You'll never remove the need for human work, I don't think. But if you can get it consistently accurate and precise, you could have it sort of help check over work, help locate formulas more easily, help ensure safeguard checks are done to a correct level. So I don't think you can ever fully replace it, because there's some stuff that need human initiative and intuition, but I think it could be a massive help. Yeah.
Where would humans still need to be involved when it comes to it? 'Cause like you said, if AI can't do everything, where would we slot into it?
A lot of it would be the hands-on work, because chemical engineering is still a very hands-on industry. So an AI can give you the formula, can tell you what you need, what you should do, and where you need to do it. But then when you've got a spanner or a wrench in your hand and you're trying to fix something. There will obviously be stuff as you're working with real life materials that the AI can't simulate accurately for. So while I think it's good for a lot of the theory, again, a lot of the practical work and sort of past experiences from chemical engineers will come in handy.
Speaking of formulas, could you take me through like a very, very basic chemical engineering formula or
Yeah, sure. So the first one that springs to mind would be the overall heat transfer overall mass heat transfer. So basically what it is when you're working with chemical reactions, obviously a chemical reaction releases energy, and you have but you want your reactor to stay at a constant temperature. So you have to calculate how much cold water, how much energy is being produced, so you know how much you need to take out and put in. And I don't have. There are obviously 20 or 30 different equations you need to know for that, and I don't have all of them off the top of my head. But the one I do have is also a chemistry equation. So it's you got Q is equal to UA and then delta T, which is heat transfer rate is equal to the overall heat transfer coefficient, because every material transfers heat at a different rate. So like you know, like good conductors, like if you put something metal in the over fire, it gets hot very quickly compared to something like, say, plastic or polystyrene. If it's not burning, it takes a lot longer to get slower. So that's what the overall heat transfer coefficient does for all substances, not just solids. It will do it for the fluids in the system, gases, etc. A's area, so the area of the thing you're working with, and delta T stands for the change in temperature. And for chemical engineers, delta T, we try and use standardized units, so almost always normally being Kelvin.
trying to picture all of that in my head. I'm not a chemist.
I'll try and give you a real world example.
Okay.
When you're baking a cake, you want the oven to be at, say, 180 degrees. And now let's say hypothetically the reactions that happen inside this cake is a special cake for whatever reason, but they're producing a load of energy, and that energy's skyrocketing the temperature in the oven. So you use that information and you use how good the conductive materials are within the oven, like how well they conduct heat, and you calculate how much heat is being transferred in and how much heat you need to transfer out, basically, through it.
I would have thought of that.
Yeah, obviously we're not using cake, but it's sort of a general sort of idea of how it'd be done.
Really quickly, if you're enjoying this episode with James Graves about chemical engineering, then please like, comment, and subscribe so that we can make this show grow even bigger. That would be greatly appreciated. Alright, now back to the episode. What are the types of jobs that chemical engineers can do? Like job titles.
Job titles.
Yeah, what do those jobs involve exactly?
So I think the biggest one is not a job title specifically, because obviously you have different levels of seniority, but you'll have people that design and manage oil and gas plants. So the designing one, you're taking in sort of all the factors, so the energy produced by the reaction, the velocity the fluids will be traveling at, the equilibrium of the reaction, the separating of substances, sort of everything. And then you also have chemical engineers overseeing the construction and managing safety features as well. So health and safety is also a huge part of chemical engineering, because obviously if stuff goes wrong, you have potentially very volatile very volatile and flammable substances just released into the open atmosphere. And then sort of water treatment, it'd be sort of senior sanitation officers, sort of less, sometimes it would be hands-on, sometimes it would be from a managing point of view. It would really depend. And obviously a lot of it's also designing plants. So my design project where we designed a reactor, again, a lot of it's design work we do as chemical engineers, designing, simulation, that sort of thing.
Just how difficult is chemical engineering?
It's tough. Like I say, I think any engineering discipline requires a lot of sort of critical thinking and sort of maths and science abilities. But while I'd say it's tough, I wouldn't say it's the toughest discipline of engineering. I'd say if you're looking at something like mechanical, which sort of goes into like aerospace engineering, so I'd say something like aerospace engineering and mechanical engineering are probably slightly tougher based on comparing my friends' experiences to mine from the year.
Why, just how difficult is aerospace engineering compared to your field?
It's a lot more sort of higher level sort of maths and physics, but you're still trying to apply it to real world solutions. So obviously there's one thing doing sort of maths for maths sake, which in itself is extremely difficult and challenging. But when you're trying to take sort of maths that goes well beyond anything you'd have done at A level, and you're trying to apply it to a real life jet engine, you can see where the challenge might arise.
And with all the safety regulations with air travel anyways.
Oh yeah, and all the safety and all the risk analysis. But risk analysis, oddly enough, is one of the easier parts of engineering, because a lot of it, you just apply common sense. So like say you have this hot chemical that reacts really well with aluminium, and you have aluminium pipes. What would be the correct health and safety thing to do? Replace the pipes with something that isn't aluminium. And while a lot of it requires innate knowledge, a lot of it you can just use common sense for, which makes it a bit easier as well.
What advice would you give to someone who wants to go into chemical engineering?
I'd say focus on maths. The most important, I would say, I've not done a single assignment and I've not been to a single lecture which hasn't involved some maths of some kind. You don't need to be like an absolute maths genius. Like I did well at A-level maths, but I wouldn't say like I was doing A-level further maths. You need to work really hard at maths, and then make sure you have good knowledge of the sciences. Now, whether you choose to do that through A-levels or a different qualification, I'd recommend working hard on that. And then I'd also say read up on what chemical engineers actually do. Because when I was doing my personal statement, I read through some articles on sort of different areas of chemical engineering, and make sure it's something you actually want to do. Because if it's not something, I found it with some of the people that chose my course that didn't love engineering or didn't enjoy engineering or didn't want to be an engineer, they really struggled with it, because it's not one of those things where you can just sort of half like and half do. You have to enjoy or want to be an engineer and have to be willing to put in the work to do that.
I've mentioned it on the show in the past, but is it one of those things where you don't have to enjoy it 100%, but you've got to enjoy it enough to where you can keep going?
Yeah, it's pretty much. It's not like say when you do a subject at school, I, for example, hated English, where you can drag yourself through sort of English GCSE if you just have the patience for it. Basically, it's not one of those things because I think with any degree you're dealing with much more complex ideas and concepts. If you're not overall enjoying it enough to put in the work, you're not going to understand it. You're going to fall behind, and you you're just not going to be able to do well effectively.
Are there any books you'd recommend to people to read on about chemical engineering, or would you stick to articles, as you mentioned?
I would tend to stick to articles. There's You'll be able to find chemical engineering newsletters where you can find sort of chemical engineering news. I'd recommend going on the iChemie website. It's a really, if you're interested in chemical engineering, there's a lot of great sort of news articles on what chemical engineers around the world are doing and how that impacts people's day-to-day lives and what being a chemical engineer means and entails. And they've got a few sort of online video conferences you can listen to as well. I'd highly recommend that as well.
What are the video conferences for, in case anyone wants to go find them later?
It would be if you go onto the iChemie website, and it might take a little bit of searching around. I don't quite have it on hand at the moment, but you should be able to find something there. Some of them will be links to TEDx courses. Some of them will just be straight videos on the iChemie website. But I'd say have a look on the iChemie website, and you should be able to find something there.
What are your plans going forward with chemical engineering?
Well, I'm on summer from uni at the moment, so I've just been working and stuff. But sort of to gear up for next year, I want to improve my computer programming skills because we have a coding module next year on a program software called MATLAB, and I want to sort of get myself up to date with that. And then sort of longer term, I want to try and in my placement year find a placement in a renewable energy company, a water sanitation company, or just a company related to chemical engineering so I can gain experience on the hands-on day-to-day work and use that to find a graduate role again doing a chemical engineering related discipline.
I'm glad you brought up coding because I accidentally forgot. Apparently, I've heard this from another source, that employers for chemical engineers are requiring applicants to know computer coding. Why is that? And do you think that's a benefit when you're asking future applicants, put yourself in the shoes of the job seekers for this, where you're asking them to essentially do two separate roles? Because I get why, because it's a good cost cutting thing, but then you've got the same person doing essentially two different jobs.
I would say it's hugely important, yeah, because what your general software engineers do with programming and what chemical engineers generally tend to do are on the whole fairly different. So for chemical engineers, it's coding isn't sort of a separate job. It's to make the current jobs that people are trying to do simpler. So we use a lot of code. We learn a lot of coding for sort of modeling processes, modeling reactors, doing sort of complex maths. And if you can write computer code to do that for you, instead of spending a day doing that and 10 minutes trying to explain it to everyone else, you can get that done in an hour. And then you've got the rest of the day to sort of get your ideas across, communicate it effectively, and then troubleshoot and problem solve. And it's 100% accurate because as good as I can be at maths, I know I'm not infallible. I will make mistakes here and there. Whereas a computer is a computer code, as long as coded correctly, is much less likely to make those same mistakes.
Does it also mitigate risks? Because if you hire a chemical engineer and a coder, but neither understands what each other's doing, I could imagine that being quite disastrous, especially when you really need to get that right.
Yeah, yeah. I'm not necessarily sure it's the communication that's the problem. The communication might not cause safety issues, but it will definitely slow things down, because even if, say, I had to work with the code because it was beyond my level of knowledge, if I have a base knowledge in programming, I can then more competently communicate what I want and how I need it done, and then he can communicate back with a sort of similar knowledge. So it makes it easier to work with people, and it makes it easier to actually do your job when given the opportunity as well.
I was also thinking from a safety perspective as well, because if they don't quite understand and it goes wrong, well, you're working
Yeah.
a water plant.
And it also means that we would then therefore have the ability to double check work. Whereas if we had no computer software skills knowledge, we wouldn't be able to do any of that.
Yeah, I was quite surprised when you said that there was a big emphasis on maths for something which quite literally sounds like a science-based thing.
I think the further you go up in sort of science, the more maths you sort of use by default. So and especially for engineering principles and stuff, a lot of the equations we derive or we know, knowing the equation is one thing, applying it is another, and having good maths knowledge makes things significantly easier to apply. Because say you got a differential equation, if you can in 30 seconds identify what the equation is, how to solve it, how to do all of that, it makes it a lot easier than spending maybe 30-40 minutes trying to get to stage one of it, basically.
I guess that would make life quite a lot easier in that regard.
Yeah.
James Graves, everyone. Where can people find you if they want to learn more about you?
I've got a LinkedIn page. I'll just get up the username for that. Sorry, one sec.
You don't need to get to that.
So LinkedIn page under James Graves, and then and then I'm also on Instagram at jamesgraves__14.
Thank you for watching. If you enjoyed that episode, then I've got the entire playlist here. I've also got clips here. Subscribe for more, and I'll see you next time.